Okay, here we go. Good morning, everybody. Welcome back to Coding on Swiboe, the next generation text editor. I started the stream a little early for everybody who's watching live today because I realized that people are getting notifications as soon as I start the stream, but then it usually takes them a couple of minutes to actually show up in the stream chat. So I figured I'd just start the stream 5 minutes early or something like that, so that you guys have some time to show up. I hope I can figure out how I can actually cut those 5 minutes away when I post this to YouTube. So what do we have as top of the show business? So the first one is I actually I bought a domain, Swiboe.org. And unfortunately, if I go there, whoa, typo. Here we go. Unfortunately, if I go there, it will only redirect to the Whitelands page right now. Whitelands is another open source project of mine. And the reason is that I don't have a homepage. So I opened the bug on the Swiboe tracker for a homepage. So I think at the very beginning we only need a static site, something that like post links to the tracker, to the source code, and gives some ideas of what Swiboe should eventually be. And that can just be a static site at the very beginning, but eventually we really would like to have all the plugins listed there and like a list of all the plugins that are available for Swiboe, very similar to, for example, crates.io or the Python package index or something like that. So if you feel that you can help out with that, if you have some HTML and CSS skills, please ping this issue, and I'm more than happy if somebody else does the homepage, because I have very limited, that is like basically zero skills with HTML and CSS. Okay, that was the first thing. The second thing, after the stream yesterday, I had a very interesting chat with Laszlo in the stream chat. Laszlo is playing around with Swift these days. Swift is the replacement language for Objective-C for everything that is Mac OS X. So from Apple, of course. And yeah, I mean, we would like to have a Swift client very similar to the Python client that we're building right now. And the reason for that is that I really want a Mac OS X native GUI, right? Because Mac OS X native GUIs can be so super pretty and very fast, and Swift is a really powerful language. That is something we definitely want. And I talked a little bit with Laszlo about that, and it seems like we can maybe pair on that somehow. Maybe we can even do that on stream, though I have no idea how that could work from a technical point of view. But that's not something to worry about right now. We will figure that out as soon as we get there. And I think that's about it. Let's dive right into it. Remember yesterday we finished by having a Python client that is able to connect to our server. So that's not the code, this is the code. So we had this very tiny Rust code and this very tiny Python code, and actually all it does is we have this function create client, and that calls connect, and this connect will actually connect to a Unix domain socket, in this case temp bloop.socket. And here we have a server running on the socket, and I can now actually run this test binary, or not binary, this test Python script, and it will connect here, then it will sleep for 5 seconds, and I will disconnect. And since it doesn't print anything, we know that it works. And actually we ran into this very interesting issue yesterday, that if I rename this function to connect and rebuild and run, then it will crash. Yeah. Boom. And I actually took some time yesterday to analyze this a little bit. So first, I couldn't reproduce it on Linux. I could only reproduce it on Mac. And here's something that is really interesting what happens. So down here you can see in the backtrace, this is actually our Swiboe connect. So this is our connect function, like this one here. And this obviously calls client connect. That's also true. Can I make that a little smaller? Yes. So you can see here in the background, basically here we call client connect. That is absolutely correct. That then calls Unix connect. So this is a Mio function. Mio is the asynchronous input-output library that we're using. And that actually like calls through to yeah, and here it begins to get really weird, right? Because that calls through to sys Unix connect, this calls through to sys Unix net connect, this calls to sys socket connect, and now this calls to connect again. And interestingly enough, this call to connect calls our Swiboe connect function again. So basically, here is what I guess happens actually. I believe that we have a name collision. So there is already in our dynamic library that we're building a function that is called connect. Probably that's the low-level connect function that directly wraps the syscall. And for some reason, when this syscall should get called, the linker actually wired it up so that our own connect function gets called again. And as mentioned, I was unable to reproduce that on Linux, and I'm not sure if this is a bug in Mio or if it is a bug in Rust. I opened a issue with Mio now with a minimal reproducible case. So we have I made very tiny GitHub repository that shows the error on my system. And I hope that Carl has some idea how we can actually get rid of this problem, and maybe if it is a Rust issue at all. Maybe it's not even an issue at all. I mean, C doesn't have any concept of namespacing, right? So there are actually name clashes possible if you have the same name of if different functions have the same name, there's no guarantee which function gets called. So maybe Rust cannot even offer that guarantee either. But for us, what that means is that we are going the safe route, and we will actually start all of our public functions will get namespaced. So basically, this is how did I call it before? I think create client. Yes. But we will actually rename it. I really like connect, but we will actually call it Swiboe connect, right? So we namespace it. We start all of our functions with Swiboe. Same here for disconnect. We also call it Swiboe disconnect. And that guarantees, or it doesn't guarantee, but it makes it very unlikely that we actually have name clashes. And that reminds me of the good old days, the good old C days, where you had to do that for all the code you ever wrote. You always had to make sure that you prefixed your functions with a prefix that was unique so that there were no name clashes possible. Okay, so let's try that if I did the search and replace correctly. Of course, there was a little too eager. This should stay connect, and now it should work, right? And it does. So how do we continue? Let's have a look what actually. Let's have a look at what actually the client all provides, right? So here we are. This is the client. We wrap the connect call. We will probably not want to wrap the clone call. Maybe we have to. I'm not sure about that yet. So, but what can a client do? A client can call an RPC, and a client can make a new RPC. And I think this is probably what we will start out with. So basically, we make a new RPC that can be called, and yeah, that should work. And yeah, so a new function. Let's keep those functions here. Then we want no mangle, right? It has to be a public function too. So it has to be boop extern C, and it is called Swiboe new RPC. And it takes a mutable client. That is the first object it takes. And now What else does it take? Hey, good morning, Pedro. What else does it take? It actually needs to take a name, and then an RPC implementation. So what was that? That was in server.rust. Server.rust. Nope. Client RPC server. Here we are. That's where the RPC is defined, pretty sure. There it is. Like here we have it. So basically we have to implement the trait that actually provides us the call and a priority. And there will be still a bit of work. Good morning, Putz. Yeah, there will be a bit of work, people. So basically our C function has to take a client, it has to take a priority, and that will be a priority. And it will be a libc c uint16, so, like so, I guess. Of course, it also takes a name. So it will take a RPC name that will be a const c char pointer. And will that return something? No. It should return some sort of error handling. Well, back to our common add error handling. Yes, sure, Pots. I will take 5 minutes at the end of the stream for questions. I will try to do that. That looks all terrible. Sorry, guys. I cannot show you the Python code because the Rust code takes so much horizontal space. So we have to switch back and forth between Rust and Python for the moment. Or actually, if I do it like this, that should be fine. Yeah, then I can show you the Python code too. Okay, and what does that do? It starts out by mutating. So like the first thing we want is our client here will get mutated to a immutable reference to a client. Right? We want a mutable reference because we don't want to delete the client here. Like so. And now we actually want to call client new RPC, like so, client new RPC. And what does that take? Here it takes the name and then it takes a box to an RPC. So basically, the name is easy, right? The name we just have like the let name RPC name equals to to string RPC name, and so this gets the name, and now we want to pass some RPC input, something like that. And now what does RPC input look like? Basically we need a structure that is a RPC, like a callback RPC maybe? I don't know, like basically an RPC implementation that calls a C function, something like that. And what will that have? It will definitely have some sort of function. Or will it? Wow, it's pretty hard. Pretty hard to think about for me. Actually, I have to change here because we also need to take a function, right? Our callback function. Let's call it callback. And that is a function that takes... What does it take? I guess it just takes nothing, and it returns nothing either. And I'm not sure. Yeah, maybe like that. But actually, then we have here a function, and that needs to be on the heap, like so. And it's actually fnmute is the name of the functions, like so. I feel that this looks different than what we had before. I'm not sure if that will actually compile, but for let's trooper on and see where we get. So basically, for this callback RPC, we would like to implement Swiboe client RPC server RPC for callback RPC. Actually, we already imported client, so this can look like this, and that's correct, I guess, right? So this is client RPC server, and the trait is called RPC. And we definitely have a priority here, which is a U16, and we have the callback. Let's not call it func, let's call it callback. So basically, we copy and paste what we need to implement. Those are the two functions that we need to implement. And this one is easy, that is just the priority that we need to return. And this one is a little harder because, or is it? Actually it isn't, right? We just call the callback and be done with. And that's that. And now we already, we run in a couple of issues here. So first, this context, that is a client RPC server context. And right now we have to pass this somehow to our callback function, but of course for that we actually need to wrap it to make its functions available to the C client. But for now we just we punt on that by just saying, well, we ignore that. And the same for the arguments. Our RPCs cannot handle any arguments at the very beginning. So we're going from here, and now here we actually pull in serde. So we will need something like serde, extern create serde and extern create serde JSON. And for that we have to mention them also in our cargo.tuml. This is actually the cargo tuml from the from our main library, and now we need to add it also to the cargo.tuml from our C client, like so. Okay, so that should be that. And where are we? Here. Basically, that should be a minimal implementation for an RPC callback. So if I basically now say down here, well, we make a RPC, and this is actually a box new of a callback RPC, and it takes the priority that we pass through, right? And it takes as callback. Actually, what does it take? It takes this callback, but I'm really not sure. Basically, I don't think I can do anything like this, right? I cannot actually pass a function by value. I actually think I have to box it, but I'm not sure. I will actually see what happens if we try to compile that. So if we try to compile that, will that work? So we start out by getting a client, and then we make a new callback RPC, and then we pass it on to client and register a new RPC. That should totally work. So here we actually want, we have to tell Python about this new function, and I want to be precise on what it actually takes. So it does not return anything, but it takes a couple of arguments. Archetypes is actually, so what does it take? So first it takes a C void pointer, and after that it takes a C char pointer, and then it takes a what kind of C? Let me see actually what C types provides as integer types. Jesus, I cannot type today. So, oh, look at that. So we actually can be precise and can say we take a C U in 16 here. And then it takes a callback function. RPC, maybe? Let's call it RPC. And now I wish we would actually remember how we did that before. So basically I cannot remember the syntax that I used for making callbacks before. So we actually have to pull up again the C-types tutorial. Oh, sorry, you guys cannot see my browser. Here it is. The C-types tutorial, and then here we look for callback, and then they have here. This is what we want, right? So we have a RPC. We call like our RPC function that is a CUN16 and C func type up here. So basically our RPC is a C func type and it returns nothing and it takes nothing, right? So it looks like this, just like this. And I think that should be it. Oh, one thing that I would like to do is actually I would like to define a type up here and call it pointer to client, something like this. And that is actually just a C void pointer. And now I can be like, even though it will not make it any more type safe, it will actually read a little bit easier. Now basically you can see that Swiboe new RPC takes as its first argument a pointer to a client. Of course, a pointer to a client is just an arbitrary pointer, but at least if you read through that, you know what is intended. So let's build and look at all those compile errors. Use of undeclared type name libc CUN16. Okay, so I was maybe wrong about the type name for libc. So let's pull up the documentation for libc. So I went to crates.io and looked for libc, and now we're looking for the type names, and we basically want UN16 something, and it is called UN16 underscore T. And why is that not working? Oh, it's just UN16 underscore T, like so. And the other one is unresolved name RPC impl. Right, that should not be RPC impl. We give it the box. So, the trait core marker send is not implemented for the type. Okay, why? So basically what the compiler tells us is that we cannot send a like fn mute function across thread boundaries. It says it's impossible to do that because send is not implemented for this type. And I'm actually not sure. I mean, why should you not be able to send pointers, like function pointers, across thread boundaries? Actually, you have to Google that. fn mute rust send. So it actually says that it's I don't know. It doesn't say that it's sent here. That's true. Maybe I can make that implicit somehow, or explicit. Okay, let's forget about this for a second, and actually we're not calling any callbacks. I just want to get it to compile and then figure it out later, because I'm actually unsure if this syntax is actually correct. So what I would like to do is just do a call to this callback here and see if it's actually working. I know we already had that working, but I deleted the code and I forgot how the syntax was. Shame on me. Shame on me. The trait call marker size is not implemented. What? 61? What? It doesn't like it in the function definition? Okay, then we remove it for now and we bring it back later. Okay, of course, now we don't pass it at all. What's that? What are you complaining about? It says it doesn't like RPC name because RPC name is what? That's weird. It says expected a pointer to string and it found a pointer to a list of integer 8s. What? That makes no sense, right? We basically say here RPC name is, we call C string to string and that returns as a string object. So that's just like a blatant lie. Interesting. Why is that not working? RPC name as string. And here we use RPC name as string. Ah, interesting. I'm not sure why I cannot shadow this name, but so what? So what? So this compiles. Let's see if it still runs. Let's see if it does. Of course, I mean, we don't do anything, right? Basically, we actually have to do like a call here, and we call Swiboe new RPC. Also, the spelling is wrong. That's the reason. RPC name. Yeah, that was it. I probably wrote RCP, right? I always write RCP. Thanks, Pedro. So here we call the client new RPC and we call our RPC test.tests. Why not? It's our RPC, we can call it whatever. We give it the priority 100 and that is that. So let's call it and see if it still runs or if it crashes. Seems like it's running. Actually make this sleep time a little shorter so we don't have to wait all the time. And now, how did we actually pass this function before? I'm sure we had that already, right? We passed a C function from, yeah, we passed the C function before, right? But it was actually, was it an fn mute or was it just an fn? Basically, was it like that? Does that work? And is that suitable for our needs? I'm not sure yet. Core marker size is not implemented for the type ops fn. Oh, how did that work? Okay, seriously. Luckily, we're using Git, so we can actually look up how the code looked before. So here we are on my fork of Swiboe in my private fork, and here we already have the branch we have been working on. So let's look at the commit history. And I think work in progress returning strings from callback. So from callbacks, that's like basically that is what we want to look at. So let's browse the files. And here in CClient source, here we must find how that looked before. Here we are, look at that. That's precisely what we want. It's actually an external C function, right? This is what we want. Ah, silly me, trying to deal with Rust functions there. So we have an external function and it takes nothing, returns nothing, and we can just call it, right? Like so. Boom. Cargo build. that builds. So let's bring back here the RPC again. So it takes an RPC as the last one, and here we actually have a def callback, print called back. Perfect, perfect. And now we can pass this as an RPC, right? Like so. I think that's how the syntax worked. So let's run that and see what happens. Yoo-hoo! Okay, so now we can extend our callback RPC here that actually now also takes an external function like that. Let's see if that works. So it wasn't complaining up there. Let's see if it's complaining here. No. No, it's just working. That is like remarkable and a little frightening. So basically, if I now build it like that, no method named callback found for what? Oh, right, I remember. You actually have to, if you have a function pointer in Rust and you want to call it, you have to put it into parentheses for some reason. So I think that's it. I think that's everything we need. So basically, if I now change this times sleep here to actually just basically while one times sleep one. So basically we now sleep forever. And I start our client here. And now I would like to have a split terminal. How does that work? Why is that not working? I was sure that this was... Oh well. That's the reason. I messed up my caps locks. So now we go back into our terminal GUI and we build that real quick. And we actually open our terminal GUI config.lua, and what we do is we now configure a key map, right? We say when we press S, what we actually do is we call a RPC, and the RPC that we call will be the one we just configured, right? Basically the test.test, and it takes absolutely no arguments. Whoa! Now I'm really intrigued if that's going to work. So we run now the terminal GUI against our socket. That seems correct. No, that's not correct. Actually, we don't want the server. We just want the terminal GUI. And it says no such file or directory, because I'm an idiot and I actually just deleted our socket. So we restarted this one. We kill our test. We run this one, but actually we remove the remove call here. So we have a terminal GUI now. And our test is not running, so if I now press S, nothing should actually happen. Oh. Actually, our function takes a client, right? So the key map is working. And now it crashed. Oh, it crashed, of course, because what? Syntax error, end of file while passing a value. So it doesn't like this, because it's not valid JSON. So let's make it valid JSON. And now nothing happens. That's exactly what I was expecting. And now we bring up our Python client, and it will have registered the test.test call by now. And if I press S, it should actually call that. Well, that was anticlimactic. Something happened. Something happened. And what did happen is that it crashed. Yeah, that's unfortunate. Really unfortunate. So let's take a step back, and instead of calling the callback here, let's just print a line and say called. Yeah, and now we do that again. And actually we have to like restart all and everything for now. killing the terminal GUI. Resetting terminal, bring up the server again, bring up the terminal GUI, bring up the Python client, and now we press S and it crashes. Ah, that's too bad. That is too bad. Oh well. I mean, we made some progress, right? What's the stream time? It's already 40 minutes in. So I guess I will cut it here. I think we made... I mean, I'm still pretty happy. It would be nice if it actually would have just worked, but hey, can't have everything in life. So how far did we actually get? So we are able to make an RPC. We also have proof that this RPC is called from our server, because something happens if I press S, right? So our terminal GUI is actually able to call into this RPC, and then something happens. Unfortunately, what happens is not what we would like to have. What we would like to have is that we actually call this function, and this function then calls out to that. Oh, did I actually rebuild? Maybe that was the issue. Oh, I didn't rebuild, right? And you guys didn't catch it? Ah, come on, guys. Come on, everybody. Let's start it again. I can still smell success here. It can still work. I believe. Kill the server, bring up the Python client, bring up the GUI. Pressing S. Wait, something happened. Here, context dropped while still alive. Call finished. That is actually correct. That is absolutely correct. Basically, here we get the context, and we actually have to tell the context this RPC is finished. And how does that look? Sorry for going a little over, guys, but I'm really excited. I want to get this gun. And we have some tests here where we actually where I can copy and paste from how that should work here. Here, that's what we want. Basically, give me a second. I will explain in a second what this means. Is that correct? I think it is. I think it is actually, and I think I can just pass a string here. Could not find result in, it says. So where's result coming from? Where's RPC coming from? That is Swiboe RPC now. So here we actually have also Swiboe RPC. So then this is actually down here. That is an RPC result. And that should work. Context.finish. Cannot borrow immutable local variable. Context is mutable. That is right. Our context is actually not immutable. It is mutable. But we own it, so we can make it mutable. Like so. And now we are actually, like, we are legal. That should now work. So, we have to bring down the... We have to bring down everything again. What do you mean, Princess Rika, that I should give it another hour? We're nearly done here. Like, can't you smell success? I smell success. Okay. So, server, terminal GUI, and Python client. And now I press S. Here we are. Boom. It works. Great. So unfortunately, to do calling this callback crashes. But we figure out that tomorrow. So we made quite some progress today. We can now register arbitrary RPCs from Python. That also means that we can do it from C, and those arbitrary RPCs are actually getting called. We don't handle arguments yet, and we don't actually are able to call back into our Python code, but I think we can figure that out tomorrow. So I'm reasonably happy where we are right now, and I think we'll cut the stream here. So 45 minutes, I think it's the longest stream we ever had, but it was also quite some progress today. Really happy. So I'll leave the stream open now for 5 more minutes for questions. Are there any questions? Yes, you're right, Princess Rika. There are a lot of other features that we can work on after this, but we take it one at a time. Okay. What do I think about NeoVim in general? So I agreed with lots of its goals. So basically, I also felt that Vim was crusty and needed a better workflow in the sense of how it is developed. So I really think it is really good that somebody set out to modernize the Vim codebase. I was also pretty convinced that the goals would be achievable. So I like basically keeping around old plugins while getting a modern foundation into place for newer plugins. But I'm really now I'm more and more convinced that this is not a workable solution. What I mean by that is that Vim really is inherently single-threaded. It wants to do everything in a single in a single loop, and adding multi-threading to it is possible, but it is not designed for multi-threading from the ground up. And there's also a bunch of stuff in Vim that I think is really it's time that we get rid of. So, example, the Vim language is terrible and needs not to be used anymore going forward. And I also like the way they actually go about. So basically, what they wanted to do is have this GUI protocol so that you could have arbitrary GUIs for Vim. And they have that right now, but this GUI protocol actually shows that Vim is also not made for general embedding in a sense, right? It wants to know how big the buffer is. It wants to control all of the text editing. And right now, if you actually build a GUI around it, that GUI has to ask Vim how big it should be. And if it resizes, then Vim has to agree to the new size and so on. So I really feel that there's too much design like legacy in Vim that will be really hard to modernize and keep going. And I'm not convinced that keeping Vim language like VimL around for another decade is really a good idea. So that is why I actually believe there's plenty of room for an editor like Swiboe. Oh, you're right, Okras. Rust is missing in the title. I will add that when I export and for tomorrow. So, coding on Swiboe in Rust. Update. C client is not written in C. No, that is absolutely and fully correct. The C client is not written in C. But it is still a C client, right? Because what I'm referring to there is the ABI. And the ABI, that means how one function, like one library can call into another library. And this ABI is the C ABI. And that is actually why we have to use no mangle and extern C and stuff like that. That will actually tell Rust that we would like to have a function that is has exactly this name, Swiboe new RPC, and actually uses the call conventions for C. So this will actually make a function that is compatible with the C ABI. And now you can write a header file, and then you have a header file in the library, and you can use C to actually link against that. But you can also use any other language that supports the C ABI, like for example Python using C types. Princess Rika, am I going to switch from Vim to Swiboe? Well, that all depends, I guess. I mean, I've been using Vim for nearly 20 years now, and I actually fully expect to switch to Swiboe in the next year. I don't know if you will or not. I think it will appeal to like a lot of people, but I'm not sure if it will, like, if a lot of people will switch away from Vim. Yeah, that's right, Princess Rika. Like every language ever supports the C ABI. That is actually why we target it. Because if we have a solid C ABI client in place, we get a Ruby client for free. We get, oh, not for free, but very cheap. We get a very cheap, we can implement really quickly a Ruby client, really quickly a Lua client, really quickly a Swift client, really quickly a Python client, and a C++ client, and an Objective-C client, and whatnot. So basically, I believe that is the way to go. Having a shared library that has a very simple API will allow us to write plugins in any language very quickly, and not like the dumbed down version that Vim provides, because Vim you can also write plugins in many languages, but all the other languages that are not VimL are really limited. But for Swiboe, every language will be as powerful as any of the other languages. Okay. I don't see any more questions for now. I'll cut the stream here, and tomorrow we can figure out why we're actually crashing here. And yeah, talk to you guys tomorrow. I'll stick around in the stream for a while longer if you have more questions. Not in the stream, in the chat.